Hey guys, today's lesson is going to be on motors and generators. Motors and generators. It's boring. I'm going to get through it fast. It's on page 18 of your book. Basically, a motor uses a battery. Okay, so you have to know, okay, and I'm going to draw it for you. Like, here's your battery. And the battery, right, has a positive and a negative pole. And there's a wire. So here's the wire, and it's attached to a brush. So that's the brush. Here's another brush. Okay, and like when you turn your car on, the battery basically turns on, and then there's electrons that are flowing out of the battery. Okay, and the thing is, when you look at a battery and why electrons flow out of the battery, well, you can have like a 16-volt battery or an 8-volt battery. Like, you know that a 16-volt has more power. But why does a 16-volt have more power? Because if you have a 16-volt battery, like imagine this is a 16-volt battery. There's a positive and a negative pole, right? And versus a 8-volt battery. What makes this have more power? It's how tightly packed electrons are. So let's say in a 16-volt battery, the electrons are packed like super tightly together like that. And in an 8-volt battery, the electrons are sort of spaced further apart. Well, because these are packed so tightly together, this has more electrical potential energy. Okay, that's what this means, right? And so when you turn this 16-volt battery on, because the electrons are so packed, they will when you turn the battery on, they're gonna like leave the battery with more force, right? There's so many of them, they're like itching to be released. You turn the battery on, they like forcefully leave through like this wire. But if you have an 8-volt battery and you have these electrons and they're not like as densely packed, well, when you turn the battery on, these electrons will leave, but they will leave like with less force. And because that's the case, these will produce less energy, right? And this one, because these are stored so tightly, and when you turn the battery on, they're released, with so much more force. This one, right, is gonna have more, like basically more output, right? This one will have like less output. And basically that's how a battery works. So let's say you have this 16-volt battery in your car. You turn the battery on. When you turn the battery on, the electrons are forced out, they're pushed out. They travel through the wire, and the electrons always sort of follow, because electrons are negatively charged. They're gonna follow a path where they always like move towards the positive pole of the battery, right? So electrons are negative, they'll always move to the positive pole. So this is called a brush. This is called a wire. This is a battery. And this brush is connected to a commutator. Okay, so this is the commutator. And a commutator is basically like connected to, it's like this metal, it's connected to this wire. So the commutator connects the brush to this ring wire. Okay, this wire ring. Okay, so the electrons are moving. They move through the brush. Then they move through this commutator. Now they're moving through this like ring here, right? And so as they move, you guys, what is important to know here, right? So there's two magnets on either end. There's a magnet here and a magnet here. So like there's a magnet here. There's another magnet here. Okay, and just based like on my last lesson, like magnetism is created when electrons are moving, can create magnetism, right? And so when these electrons are moving through this wire here, so here's these electrons moving through the wire, they move up, they move over here, then they move through this like ring here. Well, as they move, they are generating like their own magnetism. So you can imagine like these electrons are moving and they're generating their own magnetism. And the magnetism that these electrons generate while they move through this like ring interacts with the magnetic field here and the magnetic field here, and it causes this to spin, right? So this ring starts spinning, right? Because these moving electrons generate a magnetic field which interacts with this magnetic field and this magnetic field, and this thing starts spinning. It's like if you have a hair dryer, you plug it in, the electrons start moving through the wire, and then the fan spins and spins and spins, and you generate wind, and now your hair looks great and it's fresh, right? And so the electrons continue to move, right, all the way back to the battery, where then they're pushed again through, and that's how a motor works, okay? So a motor relies on a battery. This battery is a direct current battery. That means that the electrons flow in one direction. And so in a battery, the electrons always flow in one direction. And there's like this electrical source that is causing this like ring here to move. You need a battery in order for the motor to work. And that's all you need to know about a motor. Now that's different than a generator. So when we talk about a generator, basically what you do is like you are the one that is turning the wheel, right? So imagine that you have like this wheel, this crank here, okay, and your hand is in it, okay, so you're turning it, right? It's like you're pedaling a bike. When you do that, right, this here, when you spin it, this is connected to again, a brush. Like there's the wires here, and the wires are surrounded by a magnet here and a magnet here. So when you spin this like yourself, when you spin this, when your arm spin this, that starts causing the electrons to start moving. The electrons interact with the magnet, okay? And the electrons that are interacting with the magnet, this is the brush, right? Which is connected to, let's say, a light bulb. Ding, ding, ding. Now the light bulb turns on. Okay, so the light bulb would turn on as long as you keep cranking that wheel, and as long as those electrons are moving. Remember, a moving electron, like this electron moving through this, generates like magnetism, because that's what moving electrons do, and they interact with the magnetic field on like the magnets on either end of it, and as long as you keep cranking it, the light bulb will turn on. Like this, in this case, you don't need a battery, you just need like movement, like kinetic energy. So this is called kinetic energy, where you're using energy of movement to create a light, and this is using stored electrical energy that was in the battery, okay? So some things you need to know for this unit is like what current is. So current is just like how fast the electrons move through a wire, right? So it's like, here's the wire, here's the point on the wire. You're just measuring how fast, how many electrons pass that point in a second, right? And so the more voltage you have, the more current you're going to have, because you're pushing more electrons past that point per second, because the electrons are so tightly packed. And the more widely spaced the electrons are, the less electrons are passing that point per second, right? So that's current. So some things that you need to know is current is measured in amps. Volts is measured in voltage. And we're going to talk about something called resistance right now, and that's measured in ohms. Okay? Now, some things it talks about, like on page 18, is what mechanical energy is. Mechanical energy is just movement, energy that's in movement, and chemical potential energy is energy stored in chemical bonds. And that just means like this is sugar, and this sugar molecule that you eat has energy stored in its chemical bonds. And that's all that means. Okay? Okay, so batteries contain stored electrical energy, and that's all you need to know for motors and generators. And what we're going to do right now is I'm going to teach you about circuits and current. You know that a direct current is current that is in one direction. The other thing you need to know is what an alternating current is, alternating current. And an alternating current is just like electrons that move back and forth through a wire, right? So if this is your wire, a direct current will move in one direction the whole way, like this. But if it was an alternating current and the electrons are moving through the wire, they're going to move back and forth, like in a rocking chair, back and forth, back and forth. Our power and in Edmonton, like, comes from these big generating plants, and all the electricity that moves through the wires in Edmonton move through it in an alternating current. Now, it doesn't matter if they're moving in one direction the whole way or if they're moving back and forth. A moving electron, no matter what, generates a magnetic field, okay? Really important to know. Okay, so what I'm going to look at right now is currents and circuits. Okay, so I'm going to draw a circuit diagram. I'm on page 22 in your book, and there's a lot of terminology there on page 22, but this is what you need to know basically. If I draw a circuit, okay, this symbol means a battery, okay? So this battery is connected to a wire, and that's what I'm drawing right now. And this wire, right, is moving through, these are resistors. A resistor is anything that resists the current or the movement of electrons. And so, like, if you have a light bulb resists the current. It slows the current down. Because a light bulb uses the moving electrons, right, to make light and heat. So basically, you're taking this moving electrons, this kinetic energy, and you're converting it to a different type of energy, like thermal energy and light energy. So that's what you're doing. You're having an energy conversion. And you always lose energy when you have this energy conversion. So this is a resistor, and it's resisting the electron flow, right? Electrons slow down. And what happens here, well, they don't really slow down, but the electrons are being used to make light and heat, okay? So that's a resistor. Here's another resistor, and this is the symbol for a resistor. And then here you go. And here's a very simple circuit. So if you turn the battery on, the electrons move, okay? And remember, if you're dealing with a battery, the electrons always move in a direct current, meaning they move in one direction. And I call this a series circuit. And the reason why I call this a series circuit is because these light bulbs are arranged in a series, like right beside each other. And in a series circuit, if this part of the circuit is broken, like right here, let's say we break it here, well, this will work, but this will not work, right? So if you break a connection in a series circuit, then and when the electrons come back, actually, this also won't work. So one resistor breaks or one light bulb breaks, then everything in the circuit is not going to work either, right? Because if this is broken, then the electrons have no path to travel, and so how will the electrons come back to even light that lamp up, right? So that's a series circuit. And then a parallel circuit looks like this. A parallel circuit is, you can see, like, these resistors are parallel to each other like that. Okay, and here's the battery. And you can see in a parallel circuit, if I have a break here, let's say I have a break here. Well, if I have a break here, the electrons can't flow here, but the electrons can still flow here, and the electrons can still flow here. So even if this part is broken in a parallel circuit, and it's called a parallel circuit because you can see these lamps are parallel to each other. Even if this circuit breaks here, well, the electrons still have a path to flow. They still have a way to flow that will lead them back to the battery, and they can be pushed through again, right? So that's a parallel circuit, and that's a series circuit. Now I'm going to draw another circuit because there's some stuff that you need to know about circuits. Here's the battery. Here's a resistor. Here's another resistor. Here is an ammeter. Okay, and here is a voltmeter. Okay, so now don't forget, this is the battery, and this is a voltmeter. And so the voltmeter is measuring, like, the difference in charge across the battery. You can also put a voltmeter, like where a resistor is, to measure the change in voltage from the electrons moving through the resistor and after the resistor. And this voltmeter is always found parallel. It's always found parallel to a resistor or a battery. And this is the ammeter. And this detects, like, the current, so the movement of the electrons, how fast they're moving through the wire. And this is always found in the circuit, like not parallel to the circuit, but in the circuit. like in the series circuit, right? And so that's where you put the voltmeter and the ammeter. So the voltmeter always is parallel to like a resistor or a battery, and the ammeter is always found within the circuit, okay? Voltmeter measures the voltage of like the battery or the voltage or the volt difference over the resistor. And so that is basically all you need to know with how to make circuits. And now we're going to do some calculations with circuits in the next lesson. Okay? Hopefully that makes sense. Okay, bye.